Hello folks, this is Pierre-André Mathieu, and I'm here to show you a tutorial on how to set up an inertia jump. As you can see here, whenever I'm in the air, I can at the very least move the player character a little. How all this makes sense? Well, that's exactly what I'm going to show you on today's tutorial. As you can see, what I have here is get inertia jump, and it's classified as a function. I click the plus button to create a new function, then I rename this to get inertia jump and convert it into a pure function by placing a check mark on pure. Once I've done that, I'm going to double click and see what's inside. I'm going to break this down piece by piece so that way you can get the gist of what I'm getting at with this function. The input vector is the player's directional input, and it's simply used through the left analog stick or the keyboard's WASD. And from here, I normalize 2D, which takes the input vector and ensures its length is exactly 1, which means it represents a direction without indicating how difficult the player is actually using that input, which is the left analog stick or the keys WASD. And then from here I break vector, and in doing so I separate the 2D normalized input into the components x-axis and y-axis. This may not make sense to you, but I use make vector to reconstruct a 3D vector. It takes the x and y components from the input and set it to 0 on the z-axis. What this does, it gives me a 3D vector to represent the player's desired movement direction on the horizontal plane, assuming y is forward, backward, and x is left and right. What I meant to say, y is forward and backward, whereas the x-axis is left and right. As for the camera yaw, this node gets the camera's horizontal rotation rotate vector is an important step because it takes the player's 3D movement vector and rotate it by the camera yaw, which means the player's forward input will always align where the camera is facing, which is a staple for most, if not all, third-person and first-person character controllers. This one here, the vector length, calculates the magnitude of the rotated vector. If the input was normalized and only rotated, then the length should be at least 1 unless some other operation changed it, which is not entirely the case here. Now, moving on to character movement, and the target here is the velocity. This is on a different path because it's getting the current velocity of... I'm gonna stop here. When I say this is a different path, I'm saying that it's currently extracting the current velocity of character movement component. This node here multiplies one x-axis and y-axis, and next to it, yeah, I'm not gonna explain it that much, but what I can say is it either multiplies or separate an input for a different calculation, or maybe a default value, that is to say, if the target velocity is 0. This one here is player character moving. Okay, if this boolean is true or false, I have to check if the character has any significant velocity or input. This one here chooses between two inputs based on the Boolean condition, which is this. The return value of is player character moving node is connected to this very index. Now, if this is true, it selects the input connected, which is the return value of the vector length node, the magnitude of the rotated input vector. But if it's false, then it selects the input connected to the target velocity from the character movement component. Now, this relates to the inertia jump because inertia jump, as shown in games like Devil May Cry, is a technique where a player maintains or even increases the horizontal speed after initiating a jump, often using momentum from a slide, sprint, or other movement abilities just before or during the jump. The entire premise is to cover more distance or reach higher places than a standard jump. It's possible to fine-tune through air control because it makes the inertia jump feel good that the players might need a little bit of air control to slightly adjust the direction while in mid-air. It's where the input vector and rotate vector chain might come back into play, but scaled down for the sake of air movement. And there's velocity decay. You might not want to maintain full speed infinitely, so you can gradually reduce the horizontal speed over time while airborne. For jump height and leg modifiers, occasionally performing the inertia jump at maximum speed gives a slightly higher or longer jump. To test it out, I'm gonna add a breaking point to see if I get my point across. When I press the button, it shows. So yeah, it's working. Now for those of you who don't know about this, well, I'm gonna double click and show you how this goes. Okay, this is player character moving. It's a blueprint function, a rather reusable piece of logic to be precise. Its purpose is to determine with great certainty whether the player character is currently attempting to move based on the input, meaning the left analog stick. Now this is a very important function because it feeds the Boolean condition into the select node of get inertia. To return true if the player is giving a directional movement input, and false otherwise is the entire purpose of is player character moving. From the input vector, the player's raw directional input, what it does is it basically uses the same input as I show you on the get inertia jump. The 2D vector length here, yeah, those two calculate the magnitude of the 2D input vector, which means that the float represents how far the stick is pushed or if the keys are pressed. Usually 0 for no input, up to 1 for the maximum input. The walk threshold is a small constant value. It's the minimum input magnitude required to be considered walking or moving. It's used to filter out the accidental stick drift or minuscule input. Now this one here, greater than or equal to, is the core check. It checks if the length of the player's input is greater than or equal to the minimum walk threshold. But only when it is true. These two here is now able to move here are Boolean variables that, okay, not one, well, technically I'm using two of those because I'm using this, but that's not the point here. This Boolean here is likely set elsewhere in the blueprint, indicating if the character is in the moving state as opposed to idle, stunned, or paralyzed. Using the AND Boolean here determines if both are true, which means this block confirms the character is both movable or state and providing sufficient directional input. The run threshold is basically the same as walk threshold but higher. This is the minimum input magnitude required to be considered running. Now, with greater than or equal to, this checks if the length of the player's input is greater than or equal to the run threshold. If it's true, if both move and input length greater than equal to run threshold are true, then this can only confirm that the character is both in a movable state and providing the input for a run. Now for the OR Boolean, If the player is either in walk condition or the run condition and is met, then the character is moving. And by returning the node, the final result of the function, which is sent back to the calling script, that being the select inside get inertia jump. I'm gonna add a breakpoint again, only this time with this function here, and let's test it out. Yeah, that's basically no different. I'll remove that. And with this, it should be able to move a little, like how it's seen in DMC3, DMC4, and DMC5. Yeah. That's basically all there is to it with the inertia jump. If you enjoyed this video, please like and subscribe to my channel for future tutorials like this, and keep in mind that what you take and learn from me is yours to do with as you see fit. Peace out, and I will see you on the next video.